So what I have over here is a pentagon. It's a regular pentagon, so all 5 sides have the same length. And we know that the length of each of those 5 sides is 13. The goal here is to try to figure out the area of this pentagon. So pause the video and have a go at it before we do this together. Okay, now let's do this together. So just to remind ourselves, if we want to take the area of a regular polygon like this, it's going to be equal to 1/2 times the apothem. I've sometimes seen this, let me make sure I'm on the right layer, times the apothem length, which I'll talk about in a second, times the perimeter. Now, first of all, what is an apothem? I didn't say an opossum, an apothem. Well, the apothem is any line that goes from the center of the polygon and intersects one of the sides at a right angle. So for example, this right over here is an apothem. This right over here is also an apothem. Let me draw it a little bit clearer, like that. And it bisects the side that it intersects. I'm not proving it here, but it does actually do that. Now, before I even try to figure out what the apothem length is and the perimeter, why does this make sense? Well, it makes sense. If you think about it, this has a lot of similarity between, a lot of similarity with the area of a triangle. And that's not a coincidence, because you can divide any regular polygon into a series of triangles. In this case, you could divide it into 5 triangles. And what would be the area of each of these triangles? Well, it would be 1/2 times the height, which is the apothem length, times the base. And then if you wanted the areas of all of them, well, you would have 5 of these bases. And so another way to think about it is it would all boil down to this formula right over here. You can try that if you like. But let's get into it and actually try to figure out the apothem length, because they don't give it to us here. They just give us the length of one side. And to figure that out, we're going to have to figure out a little bit of trigonometry. So the first thing to realize is if we were to go all the way around, that would be 360 degrees. But if we wanted to just figure out, if we just wanted to figure out this angle here, what would that be? Well, that is 1/10 of the way around. One way to think about it, let's divide all of these, or draw some apothems on all of these triangles here. And you can see that there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 equal sections that we are divided into. So the angle is going to be divided into 10. So that 360 degrees, 1/10 of that is going to be a 36-degree angle. Now, why is that useful? Well, we know this angle. Do we know the length of this side here? Well, this side here is going to be exactly half the length of that side. So that's going to be 13/2, or let's just write that as 6.5. And then we could use that to figure out the apothem length. Let me write it over here. The apothem, let me just call that, maybe I'll call that x, just to not have to keep writing that. So we're going to, x is going to be equal to what? Or actually, maybe another way to think about it is, if I'm dealing with the opposite and the adjacent side to the angle, that sounds like tangent could be useful. Tangent is opposite over adjacent. So I could say that the tangent of 36 degrees is going to be equal to 6.5, the length of the opposite side, over x, over the apothem length. And so if I wanted to solve for x, I could just multiply both sides by x and divide both sides by tangent of 36 degrees. And I would get x is equal to 6.5 divided by tangent, let me do the same color, tangent of 36 degrees. Tangent of 36 degrees. So that's the apothem length, this value right over here. And then what is the perimeter going to be? Well, the perimeter is just going to be, each side is 13, and so it's going to be 13 times 5, which is equal to, that is equal to 65. And so our area, our total area, let me write it over here, our area, I'll just do capital A for area, is going to be 1/2 times the apothem length, which is 6.5 over tangent of 36 degrees times 65. And now let me get out a calculator here. Okay. And let me make sure that I am in degree mode. Let me just make sure it's, if I were to say the tangent, if I were to say 45 And tangent, yes, it is in degree mode, just making sure. So let me clear things out. So if I have 1/2, 0.5, times, I'll just do the 65, times 65, times 6.5, times 6.5, divided by 36 degrees tangent is equal to 290.76. So I could say that's roughly 291. Well, actually, I'll just go all the way to the hundredths place. So this is going to be approximately 290.76 square units as the area of this regular pentagon.